So last issue, right? Let's. I know we've been gone 3 days. We'll just take a second, get back up to speed here. So where we left off on Friday, we talked about solving systems, right? We spent some time reviewing how to solve linear systems, which is not a big deal. And I showed you a trick on your calculators for solving linear systems graphically. I'm going to show you another trick today like that, real quick one. The other thing, in fact, I'll even show you a different way to do it without solving it into your calculator. I wanted everybody to see that, but I'm going to show you another app if you use Desmos. Raise your hand if you've used Desmos, the Desmos graphing calculator. Oh, it'll change your life. It's amazing. Seriously, it's the best day of your lives today. No question. I'll show this to you. You can use it on the tests. It makes life really simple. But starting things off, I want to look at how we can algebraically solve some slightly harder linear systems, some linear quadratic systems, slightly harder situations. So stuff like this, we want to find all real solutions to the linear quadratic system. So the top equation is quadratic, it's got an x squared, and the bottom equation is linear. If we were to graph these, what we'd end up getting, the quadratic equation, of course, is going to give us a parabola, right? And the linear equation gives us a line. So what are the different ways that a parabola and a line could interact? What could they do? How many times could the line intersect the parabola? It could intersect it twice, right? It could do something like that and intersect it in two distinct places, right, at 2 points. It's possible that it could just graze it and intersect at just one place. Or, what's the other thing that could happen? What if it did something like that? Does it ever intersect it? No, so it might miss it completely and there might be no solutions, right? Okay, so we want to find all the places, we want to find the ordered pairs corresponding to the solutions of this system, right? So we might get 2 ordered pairs, we might get none, okay? Or it's possible we could get 1. So what do these look like? Let's do the algebra. Let's talk about this a little bit. So there's a couple rules that you can follow here that make this a little bit simpler. We're just going to essentially do the same kind of thing we did before. We're just going to substitute. But we want to substitute in the quadratic equation. We typically want to substitute for the variable that is not being squared. So in this case, we'd really like to substitute for y. Okay, we'd like to solve for y in the bottom equation, isolate y in the bottom equation, and plug y into the top equation. Does that make sense? So if we isolate y in the bottom equation, what do I have to do to get y by itself? Just going to add 3x to both sides, right? Everybody agree? Everybody see that? To get this y by itself. So those will cancel. So that just gives me y equals on the left side. On the right side, I'm just going to get 3x minus 2. And I'm going to put a box around that because that's my substitution equation. That's what I'm going to use to substitute for y in the top equation. Okay? So then what does that give me in the top equation if I do that? If I make that substitution, I get x squared equals y, but y is really 3x minus 2. Okay? You see what we accomplished there? That's good. By making that substitution, now we've only got x's in our equation, just like we did before. The one step more difficult that this problem is compared to the ones on Friday is that it's a quadratic equation. But that's all right. We've done a lot of stuff with quadratic equations. It's been a little while, but it'll come back to you pretty quickly. So let's talk about this then. How do we solve a quadratic equation like this? What are the steps? Remember, solving quadratic equations, the easy kind are the ones where there's only a single x and I can work backwards and isolate it, right? But I don't have a single x. I have x squareds and x's. So when I have x squareds and x's in a quadratic equation, I always start by putting it in what form? What form? What form? Somebody? Kylie, what form? What do I do to this?
Get the square out of it.
Well, eventually, right? We're gonna, but that's easier. I mean, there's some steps to that. First, I've got to set the whole thing equal to what?
0.
0. Good, I've got to put it into standard form, right? I got to get it set equal to 0. So what does that mean I have to do to both sides to get 0 on the right side? Okay, I mean I could, but I don't want to subtract x squared. I want the x squared term to be positive. So instead, I'm going to subtract 3x from both sides and add 2 to both sides, which means everything cancels from the right side. Agreed? And so on the right side, I'm going to get 0. That's good. On the left side, I'm going to get my x squared minus 3x plus 2. So that's good. That's in standard form. And now, I'm just going to solve this the easiest way possible, right? So what are my options? When I have a quadratic equation in standard form, the first thing I'm always going to try is magic numbers. There may not be any, but if there are, it makes life a lot easier. And if that doesn't work, then I'll move on to something harder like the quadratic formula or completing the square. Right? Either take your pick, either one of those options. I personally recommend the quadratic formula. There it is. To me, that just seems like an easier way to do it. It's, you're just plugging numbers into a formula instead of actually having to do a bunch of algebra. But take your pick. If you'd rather complete the square, I'm fine with that. So let's focus on this equation then. So does it factor? Can I break this apart? We're going to try the magic numbers route first. Can I break that apart into factors? What would the magic numbers have to multiply to for that to happen? These two numbers here would have to multiply to what? What do you think, Everett? What do they multiply to?
2.
You got to multiply to positive 2. Good. And add to negative 3. Right, they're going to multiply to the constant and add to the coefficient of x always. So are there numbers that do that multiply to positive 2 and add to negative 3? Let's play the sign game, and I think this is helpful. If they're going to multiply to a positive, so the magic numbers multiply to 2 and add to negative 3. Multiply to a positive and add to a negative, aren't they both negative? What would they be? Negative 2 and negative 1. Good. Now, those are the magic numbers. Those are not the solutions, right? To get the solutions, we have to go back and apply the zero product property. We know that the product of these two factors can only be 0 when either the first factor equals 0 or the second factor equals 0. So what's going to be the value of x that makes the first factor equal to 0? Riley, what's that going to be? What value of x makes the factor x minus 2 0? So what value of x would make x minus 2 become 0? Plus 2, right. And if I ever want to, I could just set it equal to 0 and solve, but usually you can just look at it and see, right? Just ask yourself the question, what would I substitute for x to make that factor 0? 2. So there's one solution, partial solution. What about this one over here? What's this one going to be? What value of x makes that factor 0? 1. Okay, now let's remind ourselves why that works. If x equals 2 and I plug it back in, I'm going to get 2 minus 2 is 0 times, who cares? 0 times anything is 0. If x equals 1, I'm going to get 1 minus 2 is negative 1 times 0 is 0. So those are the values of x that are going to solve that quadratic equation, right? But remember, we're looking for ordered pairs, not just x's. We need to know the y values that go with those x values. What's going to be the y value that goes with x equals 2? How am I going to find out? I'm trying to find the place, after all, where this parabola intersects this line. So what could I do?
Stick it in the y equation?
Yeah, I'm just going to plug it into either one of the original equations, right? But why not? Why not go back to the substitution equation? That's why we put a box around it. Right? Look what we did to get this substitution equation. We took the linear equation and solved for y. That's all we did, right? It's the same equation, but we just isolated y. So if I take this value of 2 and plug it into the substitution equation, that's going to give me back the corresponding y value that goes with it, right? So what do I get if I plug 2 in there? What's 3 times 2 minus 2? 4. So that tells us that when x equals 2, y equals 4. So one of our solutions is the ordered pair 2, 4. I'll put a comma to separate it from the other solution. What about over here? What if I take the value x equals 1 and plug that in there? What's 3 times 1 minus 2? 1. So then the other solution is x equals 1, y equals 1. So in Moodle, this is what I would enter. Those are the 2 points of intersection, or the 2 solutions. Okay? That make sense? A common mistake here is to put these in the wrong order. Remember that sometimes I'm going to solve for x first, like I did here, and then plug in to find y. In other situations, we may end up solving for y first and then plugging that in to find x. But when I write my ordered pairs, they always have to be in the order x coordinate, comma, y coordinate, right, for each one. Okay? Let's try another one. Questions on that, I guess, first. Okay? So we're going to substitute, come up with a quadratic equation, solve the quadratic equation, and then substitute each of our solutions back into the original to find the other variable value, right? So let's try another one. How about this guy? So stare at that for a second. Everybody should have your notebooks out. I insist. Get those notebooks out if you don't have them out. Go through this process. I am recording this, but I think going through this with me is going to be helpful. Okay, so Nick, in the quadratic equation, which variable is being squared? Y is. So then which variable do I probably want to substitute for? What do you think? Probably not y, right? Substitute for x. So I want to substitute for x, so that means when I go down to my linear equation, I want to isolate x. So what's the one step to get that x by itself? What do you think? Add 3y. Good. So I'm going to get x equals 3y plus 18. What should I do to that equation? That's my substitution equation. So what should I automatically do? Put a box around it. Because that's what I'm going to come back to that one, right? And then my first equation is going to become the quantity y plus 6 squared equals x, which is this. Okay, so I want to talk to you for a second about how do we expand this out. I want to show you a good shortcut. Okay, here, I even wrote it on the board. Here it is. Here's my shortcut. So whenever you have, I'll write it up on the whiteboard also so it's on the video. Whenever you have something like this, if I have something plus something quantity squared, there's a really easy way to expand this. You always have the option of just writing it as something times itself and distributing. That's the long, tedious way. And there's a chance you can make a mistake, but if you're careful, you won't. But there's a quick shortcut. The pattern for this, it's always going to come out to be whatever the first thing that's being added, that squared, plus 2 times the product of the first thing and the second thing. So 2 times whatever A is times whatever B is, plus the second thing squared. It's that pattern every time. Every time you have something plus something that's being squared, or something minus something. The only difference is that would just mean that B is negative. Big deal. Okay? So let's apply it to this situation right here. If I have y plus 6 squared, then what's that going to expand to? That whole thing is going to become first thing squared plus, what was the second term? 2 times the first thing times the second thing. What's 2 times y times 6? What's that going to simplify to? 12y, right? 2 times y times 6 is the same thing as 12y, plus second thing squared, 6 squared is 36, and that just equals, in this case, 3y plus 18. Okay? So what's my next step going to be then? Jace, I've got this quadratic equation. I've got y squareds and y's in it, right? What do I need to do to that? I need to put it in what form? Set the whole thing equal to? No, I've got just y's up here. This is good. But to solve this thing, I got to get it into what? Standard form. Got to set it equal to 0. So what are the two things I got to do to both sides to get 0 on the right? What do I have to do to that term? Subtract 3y to the left side and subtract 18. Good, so that's going to give me y squared. 12y minus 3y is going to give me 9y, right? 36 minus 18 is 18. So there's my equation in standard form, right? So Tyler, what am I going to try to do first? What's the easy way to solve this? Well, I can't. You're right, I can use the quadratic formula. But I might first see if I can break it apart using magic numbers, right? We're just going to check. So if I can, that would have to be the template, right? If we can factor it, if we can undistribute this thing. Okay, so Angelica, can you find numbers that multiply to 18 and add to 9? Think about factors of 18. Two numbers that multiply to positive 18 and add to 9. I kind of put you on the spot there. Anybody think of some? 6 and 3 would work. Good. Plus 6 plus 3, right? Okay, and so then what would my solutions be? What am I going to get? Kind of easy. What am I going to get for the first one here? Okay, so that's going to give me y equals negative 6. This one's going to give me negative 3. Now I want you guys to see that I didn't, what if I didn't see those? You don't have to do it that way. It just is easier to do it that way. I could have just as easily said, okay, I've got this quadratic equation. We'll come back to this in just a second. I just want to show you something here. So I've got this quadratic equation in standard form. I could just say, okay, well, let's compare this to the quadratic formula, right? Quadratic formula says, in this case, I've got y's instead of x's. No big deal. I just make those y's. So if I've got something of the form a y squared plus by plus c equals 0, then I know that y equals negative b plus or minus square root b squared minus 4ac over 2a, right? I could plug this into the quadratic formula, and it would work. So I would get y equals, what's going to be negative b? Negative 9, right, because b is 9, plus or minus square root b squared, so what's 9 squared? Minus 4 times 1 times 18, right? All divided by 2. Okay, so that gives me negative 9 plus or minus, well, what's 4 times 18? 72. So I get the square root of, this becomes the square root of 81 minus 72. What's that? 9. All over 2. So then that's going to give me y equals negative 9 plus or minus square root of 9 is just 3, right? So if I take the plus sign, what's that going to give me? Negative 9 plus 3 is what?
Negative 6.
Okay, divided by 2? Negative 3. Okay. If I take the minus sign, what's negative 9 minus 3? Divided by 2? Okay, so I could get my solutions using the quadratic formula, it's fine. Or, more easily, I could just get them this way, right? In this case, because the magic numbers did work. And then what's the last thing I would do there, Emma? Where am I going to plug those values of y to get the values of x? Good. Yeah, good, perfect. We're just going to go right back there, aren't we? So if I plug in -6, what's 3 times -6? Plus 18? 0. Yeah, so one thing I get the ordered pair x equals 0, y equals -6. What if I plug in -3? What's 3 times -3? Plus 18? 9, yeah. So then the other ordered pair would be x equals 9, y equals -3. So there's my solution. Okay? Let's look at just one more quick one. There's one other kind of thing I want you to see. Yeah, this will work. This is a good one. Okay, so what about this one? Have a quick look at this. Nick Bauer, what's the in the quadratic equation, which variable do I probably want to substitute for? Oh, the y, good, because the x is being squared. Okay, so we'll solve for y in the bottom equation. It's already done. It's already solved for y, so we'll plug that in. And we've got to be a little bit careful with this now. We're plugging that in just for y, right? So in the top equation, we're going to get x squared equals negative. And then always put a quantity there if there's something else being done to that variable. In this case, it's being multiplied by -1. Right? So we have negative the quantity. And then the substitution turns that y into 2x plus 5. And we're going to subtract 6 from the whole thing. So what do I have to do to simplify that? Okay, I've got to distribute the -1. Right? It just changes the sign of both those terms. So that's going to give me x squared equals what? -2x minus 5 minus 6. And so now if I combine like terms, x squared equals -2x. What? Okay, so what do I have to do to this? Next step? Set it to 0. So we're going to add 2x to both sides, add 11 to both sides, and that's the quadratic equation. Now this time our magic number is going to work. Are there numbers that multiply to 11 and add to 2? Aren't, right? So we got to use the quadratic formula. Okay, I want you to see something here important though. For this quadratic formula, this quadratic equation in standard form, what's my value of a? 1. That's just the number in front of x squared. What's b? 2. What's c? So when I plug that in, I get x equals -b plus or minus the square root of b squared. What's that?
4.
Minus 4 times a times c, all divided by 2 times a, which is just 2. But notice, what can you tell me about the number I'm going to get under the radical here? It's going to be negative, right? Remember, we call that the discriminant. Because that's going to be negative, and if you look back at our question, it's specifically asking for real solutions on all these. What's that mean? Are we going to get any real solutions? No. And personally, I wouldn't have even written the quadratic formula out. When I saw this quadratic equation, the first thing I always do is I ask myself, okay, well, what's b squared minus 4ac going to be? I can see right away that 2 squared is only 4, minus 4 minus 1 times, or 4 times 1 times 11 is going to be 4 minus a big number. It's going to be negative, right? And so that means, what am I going to input for my answer? Right? False. There aren't any real solutions, so I just type in false, and I'm done. Okay? Make sense? Okay, so this parabola never intersects the line, right? Okay, last thing then. let's look real quick at an example using, something like this, where we're going to solve using technology. Okay, so let's put this in using Desmos. I want to show you something really cool. You can do these on the graphing calculator, but what if this had been like a y being squared here? It's really difficult to do on the graphing calculators because the parabola is going sideways and it's not a function. It violates the vertical line test, and our calculators aren't built for doing that very well. But Desmos is. I think, do you guys have a link to Desmos on all, when you log into the computers at school, is there a little icon there that links you to Desmos, like a little, I think there is, but even if there's not, it's so easy to find. All you got to do to get to Desmos is literally just type in Desmos, and then when Desmos Graphing Calculator comes up, it takes you to desmos.com. Okay, now watch this. Watch how easy this is. If I want to find out where these intersect, I can literally just type in exactly what the equations say. So I'll open up a set of parentheses and type in x minus 4. And then as I'm doing this, notice that it's graphing the equation in real time as I change it. So x minus 4, and then I'll go out there and I'll put a caret 2 to square it. And then I'll say equals y minus 2. And there it is. There's my parabola. Go down to the next line, hit enter. And you don't have to solve for y, just type it in. 2x plus y equals 17. And now look what it does here. This is really cool. What this does, it shows me that it intersects at that point and that point. If I just hover over those, if I click on it, it'll keep that up there, the ordered pairs. So I can like leave and go write it down if I want to or something. In Moodle, it wants you to round these to the nearest hundredth, so I would go back and just round those to like 5.83, and the y coordinate would be 5.34, right? And then the other one up here, if I go, and I can just kind of use the down arrow to, how come it didn't show me the solutions then? There, and if I click on those again, now I can go up and find the other solutions right there, right, where they intersect. If it's not showing up very well, I think I can just drag this thing so that's at the center. I could zoom in some more if I want to and look for that solution. There it is. Isn't that cool? Makes it so easy to find intersections. Okay? Anyway, that's it. Questions? Have at it.